Alright, welcome to the video for lesson number 13's homework assignment on end behavior of polynomials. So in class we talked about how the end behavior can be found by knowing what the first term of the function is, essentially the term with the largest exponent. So let's take a look at f of x. So f of x has a leading term of negative 3x to the fourth power. So I know it is an even exponent, but it has a negative coefficient. So that means the end behavior is going to come down on both sides. It's going to look something like that. I don't know what it's going to happen in the middle, but I know both sides are down. So to state the end behavior, we could either describe this in words or we can use symbolic formation. So I'm going to use the symbolic form. So I'm going to say as x goes to negative infinity, f goes to negative infinity. As x goes to positive infinity, f goes to negative infinity. So essentially what we're saying here is as the x values decrease, the function itself goes down. As the x values increase, the function itself goes down. Let's take a look at g of x. So the leading term is 1/2 x to the fifth power. The number is of the coefficient doesn't really affect the end behavior, just as long as it's positive or negative. So we have a positive coefficient with an odd exponent. So I know this graph is going to end and start like that. Again, I don't know what it does in the beginning, in the middle, but I do know where it ends and starts. So as x approaches negative infinity, this function g of x is going to get smaller. So it's going to go to negative infinity. As x gets larger, the function g is going to get larger as well, so it's going to go to positive infinity. Let's take a look at 2. So 2 asks us to determine the end behavior, the leading coefficient, and the zeros of the function. So I know that the leading coefficient is going to have a coefficient of 2. And I have x, and x squared, so that would be x to the fourth. This would be the first term, which tells me my end behavior is as x approaches negative infinity, the function f approaches positive infinity, because I know that this is going to end like this. I know as x approaches positive infinity, the function is also going to approach positive infinity. Then we can find the zeros. So I know the x values are going to be negative 5 with a multiplicity of 2, negative 1, and 3, each with a multiplicity of 1. So let's graph some stuff here. So I know that negative 5 is a 0, I know negative 1 is a 0, and 3 is a 0. I know my graph is going to end by going up and start by going up. I know the 0 of negative 5 has a multiplicity of 2. Even multiplicities are going to be tangent or bounce off of the x-axis, so it's going to come up there. Negative 1 is an odd multiplicity, so it's going to pass through. So is positive 3, so it's going to pass through. Probably help to go through there. I even could find out what exactly the y-intercept is if I was to plug in 0. So I'd have 2 times 0 plus 1 times 0 minus 3 times 0 plus 5 squared. So that's 25, negative 75, negative 150. I think. Let me just check that in the calculator. So we have 2 times 1 times negative 3 times 5 squared. Yeah, negative 150. So the y-intercept is negative 150. So this point here would be negative 150. So that's what our graph looks like. Notice I'm doing all that without actually plugging anything into the graphing function of the calculator. Okay, you could always use that function to check and just make sure that you are describing what you think you're describing. You just have to change your window around. Number 3, I told you in class to skip. The picture didn't show up. Number 4, describe the end behavior of the function shown below, and then determine if the leading coefficient is positive or negative, and if the degree is even or odd. So I know as x approaches negative infinity, so as this function is going backwards, it's going up, So the function f is getting larger. As the function goes to the right, it's going down. So as the x values increase, the function is going to go down. So because the end behavior goes in opposite direction, that tells me that we have an odd degree function. So I know the degree is odd. Also, I know that the leading coefficient is negative, right? Because odd positive looks like this, odd negative looks like that. So since it's going in opposite directions, I know it's odd. And since it's starting at positive infinity and ending at negative infinity, I know it's negative. All right, these are just things you kind of have to memorize. There's nothing really that you can figure out on your own there. Number 5, can you sketch a graph of an odd function that has no x-intercept? The answer to that is no. Now let's see why. If I have an odd degree polynomial, it looks like this or like this. No matter where I put the x-axis, it's going to intersect at least once. Those graphs all are going to keep going up and keep going down. So really the reason why is because the end behaviors will always go in opposite direction, creating this continuous function that goes through the x-axis at some point at least once. Now, we could have a odd function that has like a bunch of intersections of the x-axis, right? It could look something like this, but it has to have a minimum of 1, right? You can't draw one that has none. Hopefully this video is helping. Make sure that you're watching these to check your homework.